In this video, we will demonstrate how to perform statistical testing for independence versus first-order dependence in discrete time Markov chains and calculate in-step transition probabilities related to monthly snowfall levels in Frisco, Colorado. This information may be used in making staffing decisions for the upcoming season, as the amount of staff needed is often highly correlated with the amount of snow received. The context for this problem is the company Copper Mountain Resorts, a large ski resort located in the Front Range of the Rocky Mountains in Colorado.
So my name is Catherine Bush. I'm the PR coordinator here at Copper Mountain. Copper is located about 75 miles west of Denver in the Colorado Rocky Mountains. We have world-class skiing terrain. We offer several amenities and activities for families in our resort, in our village area. Tubing hill, a winter zip line, plenty of dining and convenient lodging located in our base area. So one of the things that sets Copper Mountain apart is our naturally divided terrain. The East Village offers our expert and advanced skiing and riding. And then as you work your way west, the slopes get naturally easier, which actually separates skiers and riders by their ability levels, which creates an overall great experience for our guests. We have terrain parks and one of the first super pipes to open in North America, which usually opens around Thanksgiving, and it's host to several events throughout the winter season, including the Grand Prix, which is a Winter Olympics qualifying event, so that's pretty unique to Copper. So this actually, this season marks our 40th anniversary since we were founded in 1972 by Chuck Lewis. Basically the story is he saw the area, visited Summit County, Colorado, and saw the area and envisioned a world-class skiing resort and made that dream happen just by working with the U.S. Forest Service and then several funders in the Denver area, and opened up our mountain in 1972. We had 6 lifts running for that first season. Our opening day hosted around 170 guests. So definitely we have evolved since then. The first couple of years there was no lodging on site. It was purely a ski and snowboard destination, but we've certainly evolved since then, and we're excited to open our season on November 2nd for our 40th anniversary. The area is one of the biggest areas in the United States for skiing and snowboarding visitors. I think Colorado in general, 20% of all skier visits over the last year were visitors to Colorado. So one of the things that makes us unique as well is the fact that we have Frontline Assist, which basically is a program that we've introduced over the past year or two to help with the fluctuations in our busy times and staffing needs. So we have upper management, anywhere, our CEO included. He comes out and assists with all of the departments that need some extra help during those busy periods. So parking, we're out parking cars, we're serving pizza at Solitude Station, which is our mid-mountain restaurant. Yeah, we're all hands on deck during those busy times. So we operate both in the winter and the summer seasons, which many people don't know that we also offer mountain biking, hiking, and then several activities geared towards families in the summertime. We've got a climbing wall, go-karts, a zip line, things like that really cater to families. And then nearly every weekend in the summer we're hosting events that range from adventure races to yoga festivals to music festivals. So there's something going on every weekend at Copper during the summer. And then in the winter we operate from November through mid-April, and we offer world-class skiing and events. The Grand Prix, we host that. Sensation is our annual music festival towards the close of the season, and everything from on-mountain music to skiing, snowboarding events, a winter mountain bike race. So one of the biggest challenges that we have, both Copper and the industry as a whole, is the variability of weather, because it's obviously not predictable, so that presents some challenges for us as far as snowfall. If it snows, we tend to see great skier visit numbers. If it doesn't, then people tend to choose other activities instead of skiing and riding, but that tends to be one of our biggest unpredictable factors. But some ways that we tend to combat that is by offering après-ski activities, the tubing hill. We have one of the best snowmaking systems in Colorado, so even during the early season when we might not get as much snowfall, we consistently have great snow and great terrain that people still enjoy.
Suppose that Copper Mountain is interested in determining the staffing levels for lift operators, ski patrol, etc. for the upcoming ski season. They would like to know whether the level of snowfall they receive in the month of October preceding the start of the season will influence the amount of snow they receive in the month of December or March, which are peak months for visitors. As the number of visitors and snowfall levels are correlated, necessary staffing levels are also correlated with snowfall levels. Though the problems presented are representative of one in that industry, keep in mind that all data given in this video are fictitious and for illustrative purposes only. Data obtained from the Western Regional Climate Center contains the monthly snowfall levels for Frisco, Colorado from 1950 to 1995. The monthly means and standard deviations for these levels are as follows. Letting -1 denote the event that the snowfall received in a particular month was 1 standard deviation below the average, 0 was within plus or minus 1 standard deviation of the average, and +1 was more than 1 standard deviation above the average. The following transition counts were observed from one month to the next over the snowy months in the years 1950 to 1995. Note that snowfall less than 1 standard deviation is light, and normal and heavy snowfall follows respectively. As an example, if the amount of snowfall is light one month, the snowfall was light the next month 11 times over the period between 1950 and 1995. The problem is to determine whether light, normal, or heavy snowfall levels received in a particular month is dependent upon the levels received in the preceding month. If the test concludes that there is dependence, then what is the probability the snowfall levels will be light, normal, or heavy in the months of December and March, given that the snowfall level in October was light, normal, or heavy, and should we use this to influence the amount of staffing we should plan for in these months? The problem of assessing whether the amount of snowfall received in a particular month is dependent on the amount of snowfall received in a preceding month may be determined through a hypothesis test of the following form, where P is the one-step transition probability matrix of a discrete time Markov chain for the stochastic model. Note that row I denotes the probability of transitioning into state I, and since all rows are identical in the null hypothesized P matrix, this would indicate independence of the process. The statistical test for this hypothesis against the alternative that the rows are not identical follows a chi-square test for homogeneity, with the degrees of freedom being equal to the number of rows minus 1 times the number of columns minus 1. The test statistic is given by the following, where n is the total number of observations, nij is the count corresponding to the ijth entry, and n.j is the count corresponding to the jth column summed over the ith row. If the null hypothesis is rejected, then there is evidence of some form of dependence. Assuming a first-order dependence, or that snowfall level from one preceding event is important, the maximum likelihood estimates of a one-step dependent P matrix may be found by the following, where ni dot is the row sum of the counts. Note that we implicitly assume that this process is stationary over time. That is, the probability of transitioning between light, heavy, and normal snowfall levels do not change over the months of the year nor year by year. There are statistical tests that could be used to confirm these assumptions, but these are omitted from this example. Assuming first-order dependence in a one-step transition probability matrix P generated with the maximum likelihood estimates from above, the problem of determining the probability of light, heavy, or normal snowfall 2 and 5 months from the month of October, that is in December and March, may be found by the two-step and five-step transition probability matrix, which, by the Chapman-Kolmogorov equations, are the one-step transition matrix raised to the second and fifth powers respectively. Though the stochastic process may have first-order dependence in the one-step probabilities, the n-step probabilities will converge to a limiting distribution as n gets large. As such, depending on the speed of convergence, the probability of having heavy, light, or normal snowfall initially loses its influence of the probability of snowfall amounts as time progresses.